All right, Algebra 1. we got, we're going to do this example problem from the previous video, which is all the features of a quadratic function from standard form. So we found out how to find the axis symmetry, found out how to find the y-intercept, found out how to find the vertex, the opening, the domain, the range. We got all that information. So now we're going to do an example problem. Okay. So our problem is going to be f of x equals negative 2x squared plus 4x plus 6. Now, you don't have to do this every time, but one important part is being able to identify what a, b, and c are. Okay. Our a value is always the number in front of x squared, so it's negative 2. Our b value is always the number in front of x, which is 4. And our c value is always the constant, the part without a variable, usually at the end. In this case, it's 6. Okay. Now we can find out a lot of information just based off those three numbers. Okay. For example, we know how this graph opens. This graph opens down. Why does it open down? Well, it opens down because the a value is negative. If a is negative, it's always going to open down. So we know that without doing any extra work. We also know the y-intercept without doing any work at all. Remember in the last video, we said the y-intercept is always the c value. So we know our y-intercept is 6 because c is 6. Okay. Now there's more stuff we could find out. We do have to do a little bit more work. For example, the axis of symmetry, AOS. Axis of symmetry has a formula that you do have to memorize. It's the opposite of b over 2a. So it's a line x equals the opposite of b. Well, b is 4, so we're going to use negative 4, opposite. Divided by 2, always 2, times a, which is negative 2. So that gives us negative 4 over negative 4, which of course is positive 1. So our axis of symmetry is x equals 1. Now remember what the x value, or what the axis of symmetry is. It's also the x value of the vertex. So we know half of the vertex. So the vertex is going to be the point 1 comma something. Okay. We don't know what that something is yet. But we know how to find it. If we want to find the y value of the vertex, we're just going to plug in 1. So we're going to find f of 1. So what happens, what comes out when we plug in 1 for x? All right, well, we're just going to go back to the original function, which is negative 2x squared, so negative 2 times 1 squared, plus 4x, 4 times 1, plus 6. And figure out what that equals. 1 squared is 1 times negative 2 plus 4 plus 6 gives you a value of 8. Okay. So that's the y value of the vertex. So our vertex, we already knew x was 1, now y is 8. So 1, 8 is the vertex. Okay. All right, well, knowing the vertex tells us some more information. Do we have a min or do we have a max? Well, this isn't from the vertex, but it's from the a value. Because our a value is negative and it opens down, it means that our graph is going to have a maximum instead of a minimum. Okay. But we could also figure out what that value is. We're going to have a maximum value at the y value of the vertex. We're going to have a maximum of 8. Alright, and the last things we're going to find is the domain and the range. The domain's the same as it is for all of these problems. The domain's going to be all real numbers. So fancy R, or you could do negative infinity to infinity. The range is dependent on that min and max value. There's a maximum at 8, so we're not going to get any y values that are bigger than 8. Which means all of our y values are going to be less than or equal to 8. Which is written as an inequality, or you could write it as an interval. It would be negative infinity up until 8. Alright, now I'm going to go ahead and graph that as well. We have a lot of information here, so we may as well try and graph it. Okay. Now to graph a quadratic, we usually want to have at least 5 points. Okay. So a vertex, and then 2 on the right of the vertex, 2 on the left of the vertex. The points that we already know, we know the vertex. We know the vertex is at 1, 8. Put a dot there. It's 1, 8. We also knew the axis of symmetry, which again we kind of graph with a dotted line because it's not really there. We know the y-intercept. The y-intercept was 6. It was 0, 6. Now again, the cool part about the axis of symmetry, if you know 1 point to the left of the axis of symmetry, you automatically know 1 point to the right. Okay. So we can kind of reflect that point over. Now like I said, we like to have 5 points when we do this. So sometimes we're going to have to find an additional point. How do we find an additional point? Well, you just plug in another x value. Okay. We know what happens when x is 0. We know what happens when x is 1. We know what happens when x is 2. We don't know what happens when x is 3. We don't know what happens when x is negative 1. So you just pick another x value and plug it in. Now you want to kind of stay close to the vertex. You don't want to plug in 10 because that's going to be way off our graph. But if we plug in 3, we'll be able to find what the value is when x is 3. Now again, when you're finding one additional point, you're really finding 2 because you're going to be able to reflect that point over. So we plug in 3. Negative 2 times 3 squared plus 4 times 3 plus 6 equals, let's see, negative 18 plus 12 plus 6, that's 0. Okay. So again, that's just some quick math. You could use a calculator, you could do it in your head, whatever works. So that means we have an additional point at our input was 3, our output was 0, 3, 0. So you put a dot at 3, 0. You could also flip that over the axis of symmetry and put another dot. So we now have 5 points, and we're going to be able to connect those into our parabola. Oh, that's terrible. Let's try it again. Alright, it's a little better. Again, do your best. Rough sketch. But you should have 5 points on there. Okay. Alright, so that's graphing. That's what your homework's on tonight. Alright. I'll probably add one more if you want another practice problem. But if you don't, if you want to go skip ahead to the homework, that's fine.